We're asked to use the vertical line test to determine whether this blue curve is a function. The vertical line test is just where you imagine a straight up and down line going down through, crossing through your graph. And if it crosses at two or more places, then it is not a function. Okay, that's because one input is supposed to match up with just one output. Like if I put in like x equals 10, I have two outputs. X equals 10 could give us y equals like 2. X equals 10 could give us y equals like negative 7 down here. So x equals 2 has two different outputs. It means it's not a function. And then we're supposed to describe the domain. The domain represents all the possible x values. And so you need to decide first whether there's an infinite amount of points or whether there's like a countable amount of points, like 10 points, or maybe 11 x values, or maybe there's 12 x values. Look, you could have x equals 1, and that would be a dot on the graph. At x equals 10, you could find a dot on the graph. You can actually find 2. At x equals 20, you could find a dot on the graph. But how about all the points in between? What about x equals 19.9, just a little bit less than 20? That could make a dot on the graph. X equals 10.1, that could make a dot on the graph. So there's an infinite amount of points because you can keep those decimals going. You could x equals 0.1274567, a whole bunch of decimals after, and there's still a y value that match up to it. And the way we describe an infinite amount of points is usually with interval notation. You say the smallest x value, comma, largest x value. So if you look at the x-axis, the smallest this goes looks to be x equals -2, but the default view is always so small in MyMathLab. You got to hit that zoom in button. Yeah, -2. I'm 2 steps to the left of the origin. At x equals -2, that's the smallest x value on the graph. So I'm going to use brackets to say we can include exactly -2. And then what's the largest value? The graph is pointing to the right, meaning as it goes on infinitely. X equals 20 is possible. X equals 200 is possible. There's no end, so we need to press that infinity button. And you always put a parentheses next to infinity. And the range represents all the possible y values. Okay, these arrows are diagonal. They're not going perfectly straight up, perfectly straight down. They're not going perfectly straight to the side. Look, it looks like the lowest y value might be like -6, but that's diagonal. It's going to keep going down. If you were to extend this graph, eventually you could reach y equals -100, and then you could do y equals -200. So the range, again, is infinite amount of points, is an infinite amount of y values. You could have y equals -1, y equals -1.1, y equals -1.2, 5, 6, 7. So there's an infinite amount of points. The lowest value, we never reach it. It's -infinity because this keeps going down. And the highest value is +infinity. It keeps going up.